This video is for Chapter 15 of MTB 1370, dealing with manually regulated drip rate. And to calculate drip rate using time of minutes, we take the volume, V, which has to be in milliliters, divide it by the time in minutes, and times it by the calibration, or what we call the drop factor, which is in drops per 1 milliliter. So again, that formula, summarized, would be volume divided by time times the calibration. And it's also perfectly fine to take the volume in milliliters and times that by the calibration or drop factor and then divide by time. And your answer will be the drip rate, and the units will be in drops, GTT, per minute. We have a couple examples to look at today. The first one, example 1, says the order is for packed red blood cells, 480 milliliters, to infuse in 4 hours. And we know the drop factor is 10, which means it takes 10 drops to get 1 milliliter of fluid. Now that means the drops are large drops, macro drops. Now in order to calculate the drip rate in this problem, first I would write down the formula. Volume divided by time times the calibration. So in the problem, the volume was given in milliliters already, so we just go 480 ml divided by time. The time was given in hours, so to convert it to minutes, we can times that by 60. So you either can go 4 times 60 is 240 minutes and write that down, or you could use a dimension analysis approach where you first write the time that they give you, and the time that they give you is 4 hours, and then times that by a unit fraction that would have hours on top, which would then divide out, and minutes on bottom. And we know that 1 hour is 60 minutes. You notice we're still going to get 4 times 60, which is 240 minutes on bottom, because the hours will divide out. Now we times that by C, which is the calibration, which is the drop factor, which was given to us as 10 drops for every 1 ml. Now when we multiply this out, what will happen is we will have the milliliters divide out as well, because this milliliter is on top, this milliliter is on bottom. Our answer will be in drops per minute, which is desired, and we want to make sure we round it to the nearest whole number. So if we divide 480 by 4, I know that's 120, so 1 goes in there, 4 goes in there 1 time, 4 goes in there 120 times. And then you could reduce further, because 120 over 60 is 2 over 1. So 60 goes in here twice, 60 goes in there once. Then if you multiply straight across, you get 2 times 20. 2 times 20. And 2 times 10 is 20. So again, you get that 2 there and that 10. 2 times 10 is 20, and again, that's a whole number, so it's 20 drops per 1 minute, which means there'll be a drop every 3 seconds. So every 3 seconds, there'll be a drop coming out of the IV bag into the drip chamber. In example 2, we have a lactated ringer, and we have a large IV here, IV bag of 250 milliliters to 1,500 milliliters at a rate of 165 milliliters per 1 hour. And the drop factor is 20, which means the drops are a little bit smaller. They're not micro drops, but they are smaller than the previous drops. Now again, we take our formula. We have volume in milliliters divided by time in minutes and we divide that by, times that by the calibration, or the drop factor. Now in this problem it's a little bit different because they do not give you the total time, but they do give you a ratio between volume and time. When it has 165 milliliters per hour, that's a ratio of volume over time. So that's what we use for that first fraction. Volume is 165 milliliters per hour. An hour we know is 60 minutes, so you can go ahead and put 60 minutes in there. Then we times that by the drop factor, or the calibration, which is 20 drops for every 1 ml. Now when you multiply this out, one thing that you should notice is that the milliliters divides out. The units in your answer will be in drops per minute. And you could reduce it. If you don't have a calculator, you could reduce it by hand first. 20 goes into 20 once, 20 goes into 63 times, and your answer is 165 over 3, which I believe that will give us 55 drops per minute. And that would be the drip rate. So again, what we did, when it's given to you in milliliters per hour, that is your V divided by T. So since they gave you a ratio of volume to time, that is that first fraction, V divided by T. And in this problem, we didn't really even need the total volume. You'd only need that total volume if they also gave you a total time. But since they gave you that ratio of 165 milliliters to 1 hour, we could use that as our first fraction there. And then we just have to times that by the drop factor and simplify. Now remember, when we calculate drip rate, our answer has to be a whole number, and it will always be in drops per minute for this class.